Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at angles in polygons. So a polygon is just a shape with many sides. So note, curved lengths like this don't count as sides. So this shape here is not considered a polygon. So the simplest polygon is a triangle. All triangles are polygons. So let's look at what the angles inside a triangle add up to. So for any triangle like this, I can perform this. What I can do is I can draw a line up here that is parallel to the base of the triangle. So I'm going to call this angle X, Y, and this angle Z. Now, because of alternate angles, this angle here and this angle here are alternate. That means that these two angles must be equal. You know, if this is 80, this must be 82. So I'm going to put a Z there to indicate that this and this are equal. Similarly, this angle here is alternate to that one there. So I'm going to make this angle X to indicate that it's equal to the angle up here. Now, we know that the angle in a straight line is always 180 degrees. So we have X plus Y plus Z equals 180 degrees. That means X plus Y plus Z is 180 degrees. The angles inside a triangle are the same as the angles that make up a straight line. So this explanation is telling you why the angle sum of any triangle is 180 degrees. Because what I did drawing this line here and finding alternate angles, that will work for any triangle, whether it's scalene, isosceles, whatever. So this is true of any triangle. The sum of all of its angles is 180 degrees. So we can use this fact here to find unknown angles in a triangle. So let's look at this one here. Well, finding X is actually really simple because I know that these three angles must add to 180. X will just be 180 minus 40 minus 90, which gives me 50 degrees. How easy is that? So in the second example, we have an isosceles triangle. Isosceles because two sides are equal in length. It turns out that when you have two sides equal in length, there's also two angles that are equal. It's the base angles. So these two angles are equal. So they're the angles where the equal sign touches the base, touches the non-equal sign. So I know these two angles will be the same, so I can call this angle here X. So I know that these three angles must add to 180. So 128 plus 2 lots of X gives 180, and I can just solve that equation. Subtract 28 from both sides, divide each side by 2. So X is 26. 26 plus 26 plus 128 equals 180. So how can I use this to find unknown angles in polygons with more than 3 sides? Well, we're going to use this fact on the next slide as well. So here I have two weird looking shapes. This is a quadrilateral, it has 4 sides, and this here is a pentagon because it has 5 sides. So let's find out what would be the sum of all their angles. I know the sum of angles in a triangle is 180, and I can use that to find the sum of angles in a quadrilateral. See, I can divide this shape here into 2 triangles. So I know that all of these angles here must add to 180, and similarly this angle, and this angle must add to 180. So the angle sum of any quadrilateral is 360 degrees, because in any quadrilateral I can draw 2 triangles to make it 180 plus 180 equals 360. So I can do a similar thing here for the pentagon. I can divide this into triangles. So I can divide that one, and then I can divide it along here. Each of these triangles has angles that add up to 180. So that means all of the angles inside a pentagon add up to 180 plus 180 plus 180, which is 540 degrees. So we can probably see a pattern here. If a shape has n sides, I can divide it into n minus 2 triangles. Four-sided shape has 2 triangles inside. A 5-sided shape, I divide it into 3 triangles. If I had a 6-sided shape, I divide it into 4 triangles. So this is how many triangles I can divide a polygon with n sides. So all I have to do is times that by 180, because each of those triangles has angle sum 180. So this is the angle sum, the formula for the angle sum of a polygon with n sides. It's 180 times n minus 2, this being the number of triangles you can divide it into, and 180 because each of those triangles adds to 180. So this formula works on both of these here. If n is 4, I go 180 times 4 minus 2, put that in your calculator, you get 360. If n equals 5, as it does here, 5 sides, then we have 180 times 5 minus 2, which is 540. We're going to use this to find unknown angles in polygons. So let's look at these two examples here. We're going to find the value of x at unknown angle. So let's start here. So this shape here has 7 sides. So the first thing I'm going to do in order to find x, I'm going to calculate its angle sum. What do all of its angles add up to? So the formula I had was 180 times n. N is the number of sides, so 7 in this case, minus 2. The angle sum here is 900 degrees. That's true of any 7-sided shape. 7-sided shape's called a heptagon or a septagon. So I know that all of these 7 angles must add up to 900. If I add up all of these angles without the x, they add to 625. So very simply, x is just 900 minus all of the other angles added together, which gives me 275 degrees. We're going to do something similar here. This is called a regular shape. So a regular shape is one in which all sides are equal. So that's what this dash means, all sides are equal. It turns out for any polygon, if all sides are equal, then all angles are equal. So this shape here has 6 sides. It's a regular hexagon. So all of its angles, the sum of its angles will be 180 times n, number of sides minus 2. Putting that on my calculator, I get 720. So the angles in any hexagon add up to 720. Because this is regular, I know all angles must be equal. So that means each angle here is just 720 divided by 6 because they're all equal. And that gives me 120 degrees. So far, I've looked at interior angles. They are the angles inside a polygon. So all of these angles here are interior. All of these angles are interior. Exterior angles are outside the shape. And it turns out for any polygon, no matter how many sides it has, if you add all of its exterior angles, you get 360. So this is what the exterior angles look like. What I do is I extend one of the sides, and it's this angle here outside the shape. So I just found out each angle inside this regular hexagon was 120. So this one will be 120 as well. This one's 120 and so on. So this angle here is just 180 minus 120. So I'm left with 60 degrees. So each of the exterior angles of this shape would be 60 degrees. So here, by the same logic, this angle would be 60 degrees and so on. So the sum of the exterior angles here, there'll be 6 of them. Each of them will be 60 degrees. So 6 times 60 gives 360. The sum of the exterior angles of a shape always equals 360. So that would be the same in this shape here. If I found all of the exterior angles, they'd add to 360. Exterior means outside, so if I extend this side, this would be one exterior angle, this would be another exterior angle, and so on. This angle would be 40, this would be 30. If I add up all of the exterior angles, they always add to 360. All right, let's look at a few questions that are slightly harder now. So, firstly, what is the name of a polygon whose angle sum is 2,520? So, if I want to know what the name of the polygon is, I need to know how many sides it has. So, I know the angle sum of any polygon is 180 times the number of sides minus 2. Here I'm told that the angle sum is 2520. So, I'm just going to replace A with that. So let's go ahead and solve this equation. So first thing I'm going to do is divide by 180. Because what's being done here, we're timesing 180 by the brackets. The way you undo timesing 180 is dividing 180. So 2520 divided 180 gives me 14. So I get 14 is n minus 2. I simply add 2 to each side. And I get 16 is equal to n. What have I found? I've found that a polygon with angle sum 2520 has 16 sides. So it turns out a polygon with 16 sides is called a hexadecagon. So to know that, you can simply just use Google and look it up. So it would be a hexadecagon. A polygon with 16 sides would have an angle sum of 2520. So I don't know whether or not this shape is regular. It doesn't matter. All shapes with 16 sides have an angle sum of 2520. It's just if they're regular, each of the interior angles will be equal. Let's try this one now. Each exterior angle of a regular polygon is 20 degrees. What is the size of each interior angle, and what is the name of the shape? So I know that the exterior angle of a shape is just 180 minus the interior angle. So if we have a shape like this, if this is the interior angle, the exterior angle is here. We're told the exterior angle is 20 degrees. So each interior angle will be 160 degrees. Just 180 minus 20. So we know that each of these interior angles will be the same because we're told it's regular. So to find the name of the shape, I need to know how many sides it has, but this is really easy. If each exterior angle is 20 degrees, remember that the sum of the exterior angles is always 360. So this shape will have 360 divided by 20, which is 18 exterior angles. A shape with 18 angles also has 18 sides. You can't draw a shape that has like 4 sides but not 4 angles. Doesn't make sense. This shape will have 18 sides, and the name of an 18-sided shape is an octadecagon. Again, you can just use Google for that. All right, and then we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.